Hello, my name is Ben Lewis, and this is Lab 1, Charge Tape Lab. So the purpose of this lab is to calculate the number of electrons lost by a piece of charged tape in order to understand Coulomb's law. And as a preview, the charge on each piece of tape was 1.99 times 10 to the negative 8 coulombs, and the electrons lost was 1.2 times 10 to the 11th. Coulomb's law describes the force of attraction and repulsion between two unlike or like charges, and then Newton's second law. It's pretty. So for this lab, we created two pieces of charged tape and then made one of those tapes into a bridge between two objects. Slowly moved the other tape under until the top piece started to move up, and then measure the distance. Using this information, the mass of the tape and the number of atoms in the tape, we calculated the electric force by using the gravitational force, then calculated the number of electrons lost, and then finally simulated the scenario in GlowScript. The system is the charged tape on the bridge. The surroundings is the charged tape. Mass of the tape is 0.00025 kilograms. Tape dimensions, it was an area of 0.005 meters squared. And then the atom area was 1 times 10 to the negative 20th. So in terms of number of atoms, there are 5 times 10 to the 17th. Distance between the tapes was 0.0381 meters. So the magnitude of Fg is 0.0025 kilograms times 9.81. So it was equal to 0.00245 newtons, and therefore the magnitude of Fe is the same. So the electric charge, Q, is 1.E, and then the number of electrons lost is equal to the electron charge divided by the charge of the electrons. So 1.2 e to the 11th. And then, yeah. Here's my code. So assumptions and errors, we ignore air resistance on a moving object. Treat a long tape as though it's a point charge with all the charge concentrated at the center of the long tape, and assume that each U tape you made had the same amount of charge evenly distributed along the length of the tape. Loss of charge due to handling to the environment, inconsistent charges between the two tapes, and then tape length and mass errors. So the what if electrons had positive charge and protons had negative charge, and what changed about the observations you made with the tape and the charged objects. The result would be the same since it's still two opposite charges. Why is it important to handle the charged tapes as little as possible? What happens when the charged tape comes in contact with your hands? Charged tape can become neutralized if it handled too much, as charged tape would try to regain the lost electrons from your hand. Anyway, that's it. Thank you.